And so it begins. Keith, good morning. Or good, I guess it's like super morning for you, right? Oh, I need to turn this light up. Happy Wednesday. Happy Thursday. Is it Thursday for you? Ooh, happy Thursday, my friend. So happy to see you. Whew. I don't know how much of yesterday you saw me struggle, but it's so interesting. Um, the second, almost, I guess stopping and come back. I should have just stopped. Said, okay, I need to rethink my approach here. I actually had the right approach initially, and then I went down a crazy rabbit hole yesterday. Um, yeah, I had my data structure essentially how I should have had it initially, good to go, and then I decided I was like, oh, I'll do it the cool functional Haskell way, and then the way I started implementing it used only homogeneous lists, so I couldn't have nested lists, and so I got myself all confused for about an hour before I backtracked, ran out of time on my stream because I had to go teach, and then came back to it and boom, flew through it immediately. Sometimes all you need is that break. Also, the pressure of having everyone watch me, I suppose. Being live, trying to talk while I'm doing it didn't help, I think. But I've written parsers a million times. Let's check it out. Day 13. All right. We've got. Yeah, I left. I had. I'm so frustrated because I had the right approach initially, and then I let myself fall off. I let myself go off on a crazy tangent, thinking I was super cool with my Haskell list type. A list is an element followed by a list, and that ended up being couldn't get through it. All right, let's see here. Get token. All right, so we token and rest. Yeah, yeah. So I ended up implementing mine. Well, it's so easy. This one is just you can do a recursive descent parser with a single look ahead. So you don't really need to have a parser combinator. The solution I came to, do I have that up here? This is the one I did in my video. Here's the version that I gave to my students that doesn't use. This one parses a list of objects just because I don't want to go into. I want these videos to be approachable by as many people as possible, and so I didn't go into how you could use inheritance to solve it. But it's such an easy look ahead. You just get your data, turn it into a queue, and you're just pulling off that head, consuming one character at a time, and producing tokens. That's essentially what it is. And so parser combinators almost is overkill. But, nothing wrong if you had chosen to do a parser combinator. I saw a lot of people after I started looking at solutions doing this depth thing. I didn't need to do that. That was something. So if you watched the stream, at the end of my stream last time, I was going I tried to do it sort of like an iterative way, parsing it, and then I just realized, oh, this is just all I got to do is yeah, I just let myself get off. Parser is straightforward. Well, depth. Okay. Get token. Depth. Okay. Cool. Square. Yeah, so parse a number or a list. Exactly. That's, you know, so my solution, we have the parser combinator, not parser combinator, sorry, recursive descent. We have a parse element and we get either an int or a list, and a list just pulls off elements until you get to the end, until you reach the end of the list. And then compare, the rules for comparing were just like a little bit, that's the hardest part. We sort of loop through, look at each token, check it, and then if your length is greater, yeah, so there's just some complex, I thought the most complex part, I guess the parser is actually relatively, you know, if you've not built a parser before, it's complex. And then the compare, it's just all the little details. And then for a while, I wasn't doing, the thing that got me is I thought I didn't have this less than or equal here. I was only checking things that were in order but not equal to each other, and it ran into an issue where I was off by like 3 or something. Exactly. So that's, you know, yes, it has to be exactly right. It's a little bit tricky to test, but yeah, so I was actually really happy that I was able to put together a walkthrough, sort of my guides, a guide that I think my students can follow here on how to approach this and slowly build it up. Anyway, this is it's compared big. So it gets the tokens, checks it. Okay, because you've put everything in here. Okay, I see. I broke mine into sort of logical chunks. So I have compare element, which sort of checks, pulls the ifs out. If it's an int, it does the compare here. Otherwise, it compares lists. There's one that does the list that's just straightforward. We can assume that we can compare elements in it. Cool. All right, nice job. Nice job. I wish I had not floundered around so long. I spent so much time floundering yesterday and not just straightforward approach is what I needed to do. But I got sidetracked, and then I got all, you know, by the time I was ready to actually solve it the right way, my brain was a little bit drained. We're on day 14. We're gonna see how we do. Let's set this up. Ooh. Yeah, this is finals week for my students essentially. So this is the last week of school before we go to break. So I can't believe I've managed to actually get the last 2 videos out for my for days 12 and 13. Today's day 14. I think this might be the last day I do a beginner's guide, just because it's the last 2 videos have taken so long. We'll see what today's puzzle is like and how long it is going to take me to do. Good news, today's was pretty straightforward. Oh, Keith, don't tell me that. I mean, tell me that. I'm excited. I'm glad to know that today's puzzle is straightforward, but making me nervous now, because what if I can't get it? Then I'll be the fool. We'll check it out. Let's see. All right, let's get this project open. Let's go to day 14. But yeah, I've been so motivated to make these videos because they've been doing so well, my guides. Smab, happy Wednesday, my friend. No worries. No worries. I hope that means you've been getting some sleep. I hope this means you got some sleep in and are feeling well rested. But yeah, don't stick around for spoilers. Ooh, 15 hours of sleep. That's good. That's good, I think. I mean, it's bad that you had to sleep for 15 hours, but I hope you're feeling rested. All right, I haven't even read the problem yet. We're gonna try and get my brain to wake up here. The Regolith Reservoir giant waterfall. Actually, hang on. The signal seems like it's coming from the waterfall itself, and that doesn't make any sense. Take it easy, my friend. However, you do notice a little path that leads behind the waterfall. Correction, the distress signal leads you behind a giant waterfall. There seems to be a large cave system here, and the signal definitely leads further inside. As you begin to make your way deeper underground, you feel the ground rumble for a moment. Sand begins pouring into the cave. If you don't quickly figure out where the sand is going, you can quickly become trapped. I love these puzzles. These puzzles crack me up. The storylines crack me up. So the one with the rope, it's like you're crossing the bridge and something starts going on. It's like, quickly, you write a program to solve this thing before something terrible happens. I just imagine you're in a cave, sand's coming in, you're feverishly typing to solve this puzzle. Fortunately, your familiarity with analyzing the path of falling material will come in handy here. You scan a two-dimensional vertical slice of the cave above you and discover that it is mostly air with structures made of rock. Your scan traces the path of each solid rock structure and reports the XY coordinate that form the shape of the path, where X represents the distance to the right and Y represents the distance down. XY, so okay, Y increases down. So we got column and row. That's how I like to think about it. X and Y get me confused. So X is column, Y is row. Each path appears as a single line of text in your scan. After the first point of each path, each point indicates the end of a straight horizontal or vertical line to be drawn from the previous point, for example. So this is the line segment. Oh, hang on. Oh, okay, so it's like a series of lines. So it goes from here to here, and then here. And then here to here to here to here. Okay, and then this is going to be, I've already predicted that this is going to say, and below is a drawing of the picture above. This scan means that there are two paths of rock. The first path. The path consists of two straight lines, yep. And the second path consists of three straight lines. Specifically, the first path consists of a line of rock from 4984 through 4986, and another line of rock from 4986 through 4966. The sand is pouring into the cave from point 500, 0. That's just a constant, I suppose. That's not part of our input. Okay. Drawing rock as hash, air as dot, and the source of the sand as plus. This becomes this picture. Sand is produced 1 unit at a time. So we're going to do some kind of simulation, I'm assuming, with, sand falling in. I've seen this type of puzzle before. And the next unit of sand is not produced until the previous unit of sand comes to rest. Ooh, okay, so it's one piece falls at a time. There's not multiple agents, so that makes it even a little bit easier. The unit of sand is large enough to fill one tile of air in your scan. A unit of sand falls down one step, if possible, if the tile immediately below is blocked by rock or sand. The unit of sand attempts to instead move diagonally one step down into the left. So it goes down. If it can't go down, it goes down and left. Tiles blocked. The unit goes down and right. So down, down left, down right. Sand keeps moving as long as it is able to do. So at each step, trying to move down, then down left, then down right. If all three possible directions are blocked, the unit of sand comes to rest and no longer moves, at which point the next unit of sand is created back at the source. Okay. All right, so I'm assuming it's going to ask us to fill up the space until we can't place more stuff. So drawing sand that comes from the top, and we keep going until, I guess I should read this whole thing. There's no highlighted bits. All right, so sand comes down, then it falls next to it, then it fills up like that, then it keeps filling up, fills up like that. Once 24 units of sand shown above come to rest and all further sand flows off the bottom, falling into the endless void. Just for fun, the path any new sand takes will fall this way. Using your scan, simulate the falling sand. How many units of sand come to rest before the sand starts falling? All right, so this is a let's think here. We could so we need to figure out the lowest point. All right, so if we have the lowest point, if a grain of sand falls beyond that lowest point, that means we have fallen into the abyss because there will never be anything for it to land on. So that's sort of our end condition. The sand falls. Do I need to simulate every piece of sand? Or is that a trick in this puzzle? If we simulate every piece of sand falling, well, if we think about it, we can sort of determine, so the next piece of sand is going to follow the same path except for right at the end. So we can use, can sort of backtrack. This becomes like a recursive solution that says, okay, once I find the spot, where does the piece of sand that where would I have gone if this piece was occupied? So you just sort of recur back one and then find the next path, and then recur back one and find the next path. So it's sort of this, you can think of it kind of like a depth first search that follows specific rules, and then you're filling it in. So we're going to do a depth first search, I think. Or maybe let's not call it a depth first search. But yeah, I think it's a depth first search. I guess any kind of search, as long as you follow that correct path. We're gonna do a depth first search to find our thing. So I'm gonna use a stack to keep track of all my previous positions. When I find a position, I just say, oh, well, now fill in from the next stack up and keep going. Okay, so that is my strategy here. Let's see if we can parse this in. Occupied spaces, I'm gonna use a hash set of positions just in case I need to modify a position. We are gonna do public record position. They want us to do an X and Y. I'm gonna do that. Do I want X and Y? I like row and column. Row and column is just easier for my brain to think about. So I'm gonna do row column. And we try to go, let's see, down, down left, down right. Okay, so public position array next is equal to it's gonna be equal to new position array, and can I not do that? Oh, it wants array. Ooh, you know you're tired when you forget square brackets are how you do arrays and not parentheses. What is this saying here? Unnecessary zero linked allocation. Yeah. This is gonna be this with row equals row plus 1. Can I not do this? It's not available. All right, well, we'll do it this way then. This with... so down... and column equals column minus 1. Down... down left, and then down right. Those are... that's the order of flow. Okay, so we always flow down. We can go left, we can go right. Okay, so that's sort of my pathing thought there. Let us let's parse this in. Parser or map. Maze, maybe? I don't know what to call it. Public record maze. And a maze is going to be made up of a hash set of positions occupied. Okay. And then we're going to have a parse cave. That's a good name for it. Keith, I need you to come live in a pocket on my shirt and whisper good naming conventions for me. Cave. I often, and I've probably said this already, but I always tell my students that the hardest part of programming is good naming. For me, I'm terrible at naming things. Public static cave parse string array rows. Each row is going to be a line, so we're going to start with hash set of position hide equals new. We gotta read these lines. So we have a start. Okay, so string oh no, hacky to get part 2 done. I don't like that. We'll see. We'll see how we'll see where we end up. Yeah. All right. So we're parsing here. Each row is gonna be a line segment. So I'm gonna do string. Oh, I gotta do for each string row in rows. Return cave, new cave. Occupied like this. And then we'll do a public static void hash set position line segment. So we have a start position and an end position at line parse segment position start position end, and we need to sort of increase towards from start to end. So we're gonna start by doing that position peas dot add start return peas. We're gonna go well gonna update start well start is not equal to end. Start dot gonna move it towards it, so we just have to figure it. So our diff x, diff y. Int diff x equals start dot row, start diff row start dot row minus end dot row. Let's see. So if row is, we're at 0, we want to go to 1. We need to increase by 1. So I need to flip these. End dot row. This is where we want to be, and we'll do a math dot sign. Int diff column equals math dot sign end dot call minus start dot call. So let me think. Yes, if I'm at 0, I want to go to 1. I need to subtract to get the sign. There we go. Ye old Taurus King, thank you for following. I hope you're enjoying watching me sweat trying to figure out how to do some advent of coding. I'm going to start equals new, start equals start with start dot row minus diff plus diff row comma start dot call plus diff call. Okay. Am I not doing that? All right, well, we will just do a new position then. New position. And then we add it, ps.add start. Gotcha. Gotcha. Well, I'm glad you're here checking stuff out. We are just trying to do some advent of code. I hope you learned something. I hope you learned something. That's why I'm here, I suppose. I don't know if that's really why I'm here. I like the attention, I think. I think that's what it is. For some reason, streaming is just strangely addictive. I should do it. I probably should do it less. All right. But I like talking about code. I like chatting about code, meeting cool people like yourself. So we're gonna parse this segment. Each row, we got a split row dot split on this, and that's gonna be a string positions, and then let's add a parse to our position here. Public static position. And they come in XY kind of a parse string position XY. Okay. I'm going to parse positions in the XY. I guess I should use XY. I don't know why I've decided to use row column. I'm going to stick to row column and then change it for my tutorial video, I suppose. Here we go. Here we go. We're going to split this string tokens equals position xy dot split on a comma. And then we're going to return a new position with tokens dot one. So the second one is the y position. Int dot parse. And int dot parse tokens of 0. Okay, so now we can parse in position. So this is actually, I'm gonna make this an array of position. Dot to array, and for int I equals 0, I is less than positions dot length minus 1. So we're gonna do pairs. Oh, actually, I don't even need to do that. Oh, I do need to do that. Well, given you get these columns of sand, not bad naming. No, I went with XY. I hate XY. It hurts my brain so much when I program because arrays are row and column. Arrays are row and column, so it gets my students especially, it gets them super confused. I hate using XY. I use row and column whenever possible. We are gonna do parse segment positions at I, comma, positions at I plus 1. We'll get all of the segments parsed in, and it's gonna be occupied.union. Does this actually end them, or this return? It has to have a union with. All right, so that'll actually union it. I am. Oh, you're asking if I'm standing up? I am. I use a standing desk. It's fancy. I can make it go up and down. But I have some back problems. For years, I had some horrible back problems because I'm sitting hunched over a computer all day. Excuse me, my throat's a little full here. But yeah, for years I had this horrible back pain, and I kept thinking let me try a standing desk. Let me try a standing desk, and I never did. And then there was this sale, and I got this like attachment for my desk that can move up and down for like $70. Overnight, my back pain went away, and I couldn't believe I hadn't just bought a standing desk. I was so mad at myself that I had back pain for like 5 or 6 years. Overnight gone. So now I'm pretty much not always standing, but I got a desk that can move up and down. I'd say pretty frequently if I'm at a computer, I'm standing. All right, so we got this. What is this complaining about? Oh, I have to do a select on this. Select position parse to array. And I guess I don't. Oh, I do want it to be an array because I got to do that. Okay. I don't have to. I could do some fancy trick here, but I'm not going to. All right, so this gets us our cave walls, I think. Yeah, I think this gets our cave walls. I guess I should write a test here just to sanity check that I have all of these positions. It would be nice to have just like an easy to write printing here. I guess I could make a thing that prints a window. Let's do that. That'll be fun. That'll be a fun little thing here. Public void print window position top left position top bottom right. We'll write a little thing to print the window out. There's a constant here. Can I make public const origin, public const position origin? Can I make these or new position? And it's at column 0, or no, column 500 x 500, row 0, 500. I don't think I can make these consts, right? Public static read only. Okay. Doesn't want me, it says I don't need to do that. That's cool. And so we're gonna give it a window, and then we're gonna just do for int row equals top left dot row. Row is less than bottom. Row is greater than, yeah, no, row is less than or equal to bottom right dot row. Row plus plus. And then for int column equals top left dot column, column less than or equal to bottom right dot column, column plus plus. Console if occupied dot contains new position row column console dot write line console dot write hash else console dot write dot, and we will do a new line here, console dot write line like so. We'll just eyeball this real quick. Program. We'll take our example, example input like this. Add that into an example file. Read that bad boy in. Rows equals file.read all lines sample.txt. Cave of wonders equals cave.parse rows. And then we will do of wonders dot print window, and our window is new position top left is 0494. 2, we'll do one, we'll go left one more so I can see the range there. New position 05. Oh, no, not 0. Let's go to 10504. Yeah. Let's check it out. Hey. All right. Looks like we parsed it in okay. Okay. So now we have a visual confirmation that we have loaded things in. All right. Yeah. So dropping a piece of sand. Let's think about this. What was I gonna do? All right, so the sand's gonna come in and it just follows until it can't fall anymore or is in the abyss. Falls off the edge into nothingness. So we need to get the, it'd be nice to know an int here that is the max row. So the furthest thing down here would be nice to have. Bottom max row, I think I'll go with that. So as we're adding in these positions, int max max row is going to be equal to, I don't know if we can do that, but just to be safe, I don't think we'd end up with anything that's less than 0, but we'll start at the smallest possible one. And as we get positions, we're going to do max row equals math.max of max row, or positions at I dot row. And we got to get both of them here, plus 1 max row. All right, so now we have our max row, so we know where we stop. So we want to have our sand dropping in. So I guess I have a method. Guess I'm gonna have a method called. I'm using .NET 6, Keith. I know you guys are. You guys want me to use .NET 7. I don't want to upgrade just yet because I haven't finished my Friday I finished this term, and I can probably upgrade to .NET 7. I'm also a little nervous because the book that the book that I use, my students use .NET 6. Ooh, that's kind of cool. But maybe I'll go ahead and get .NET 7. Maybe I'll have my students install .NET 7. I'm worried about doing it because I'm going to have students for this whole year using .NET 6. And I don't want to... Yeah, maybe I will. Maybe I will. I probably should. The other thing is, I think... Maybe I'm wrong. I think Replit is a tool that I use as well with my students. I think it, by default, uses .NET 6 still, so... There's just some dangers if we use .NET 7 in VS Code and then we want to share it. There's a whole thing. My year ends in July, end of May. Together for learning Java, and we're always a year behind. The newest version of Minecraft usually always comes out in the summer, and so we're always on the like a slightly old version. And my students go, "Why can't we use the latest version?" That makes sense. That's so weird for me to wrap my mind around that Christmas is summer somewhere. It makes sense, but I just don't think about it. That would be nice. That'd be nice. The cold makes me bitter sometimes. But I'm in Arizona where it's pretty warm. It's cold. It's been getting cold, but it's not too bad. Apollo, happy Wednesday. Maybe Thursday for you. It's Wednesday for me. I am working on Advent of Code day 14. We are doing a sand simulation. So we have a puzzle here where we drop sand and it fills up this space. There's rules for how the sand falls into the environment. And so that's what we're working on. We're gonna drop some sand here. So my cave, I'm actually gonna have it. So welcome aboard. I'm glad you're here. If you have any questions, don't hesitate to ask. But we are trying to work our way through this puzzle so we can save Christmas, get some gold stars. Gotta feed the reindeer so they get magical powers. Yeah, so I'm gonna add in so public void. Definitely dropping some sand. Yeah, we're going to drop sand, and we're gonna do a bool. It's gonna return true if there's more work to do. All right, drop sand. So we need to, I guess for visualization purposes, it'll be good to have a public hash set position sand. So I'm gonna have this just to keep track of the sand, so I can draw it. For debugging, I can draw it, make sure it makes sense. So a piece of sand, we're gonna have a stack also. So I decided I'm gonna use a stack to represent the most recent position. So stack of position. Back, I don't know what to call this, back tracker. I could do this recursively, but if I use this stack, I can do it one step at a time rather than letting the stack go. The system stack, the call stack. So if we're gonna drop sand, if we get to the end of this, I think we'll return true. We'll see. Might be if we get to the end, we return false because we weren't. Yeah, if we get to the end of this, we're gonna return false because that's gonna indicate that we weren't able to place sand. Sand fell off the edge of the environment. So if our backtracker is empty, count is 0, we're gonna backtracker dot push origin. So we're gonna push a grain of sand onto the top. Okay. And then we need to check if we can go to the next position. So for each position p in backtracker dot peak. Let's see here. Actually, if yeah. So for each backtracker in our peak, we're gonna take it dot next. So this is gonna give us the positions we want to check next. We'll go with next. If next dot or if occupied dot contains next. So if it's already occupied, we gotta continue. Oh, const continue. Go to the next one. If it's already occupied, go to the next one. If it isn't occupied, we are going to, if it's not occupied, we're gonna add it to the stack. Backtracker, backtracker.push. We add it to the stack saying, hey, we need to check this position. And then we can drop sand. Drop sand is just gonna say keep dropping, drop the next piece of sand. So I guess I am doing it recursively anyway. If we get to the end of this for loop, if we get to the end of this for loop, we're gonna the position that is at the top. The position okay. So if it is already occupied or it is falling off the edge, we don't want to go there. So next dot row is greater than max row. Is that right? So if it's greater than the max row, greater than or equal to, because if we're sort of next to it, I don't think it matters, but if we're next to it, we know that nothing else is beneath it. Okay, so if we're greater than or equal to the max row, we're gonna skip that position. Go to the next one. We're gonna say, all right, we're gonna go and push this on there, saying we're gonna eventually have to check this thing. We get to the end here. And the topmost position is the one that's gonna be occupied. So we're gonna say let me think here. Do I actually push this origin on there? We don't add it if it goes there. This isn't gonna quite do what I want. It's gonna fill up. Hang on. Drop sand. If All right, so we do. If the top, all right, so I know that the idea I have is that the top of my stack should be the position I want to fill. So we're gonna do backtracker.pop position to place, and we're gonna go and add that to our sand and our origin and our occupied. So that's the position. It is now filled, but we don't want to place it. All right, so we're not gonna place it if, okay, so here's it is. If to place is too far down, greater than or equal to max row, return false. Otherwise, return true. Place dot row. Yeah. All right, let's check it out, because this should. Oh, we also have to know how many grains of sand we place, so this is just kind of necessary at this point. All right, so let's update our visualizer. If if sand dot contains new position row, position p equals new position row column p console.write for sand. All right, let's check this out. I think we're in a good place. Now we're gonna say well, we'll just do a while true console.readline. We'll put this in here. Console.clear, console.readline, and then here we're gonna do of wonders.drop sand. We'll say if drop sand. Here we go. We'll do a do while. I never use do whiles, but I found a use. Do while of wonders.drop sand. This drop sand returns true if there's more work to do. Okay. Let's try it. Let's see if we can .NET run. Oh, project solution. All right. Uh-oh. Hang on, I got a double. I need an else if in here. Else if. Okay. Village. Oh no. Okay, so I'm close, but we should at this point. Okay, what do I got wrong here in my cave? If hang on, I just have my rules wrong. I don't understand the rules. Down, down, left, down, right. Okay. If the tile immediately below is blocked by rock or sand, the unit of sand attempts to move diagonally. Okay, so we actually... Cave's getting bigger. G12345. Happy Wednesday, my friend. Welcome aboard. We are trying to solve this puzzle. All right, so if there is something beneath it, it tries to move down. All right, so I just had my rule wrong. I was saying if it hits something, it stopped. The tile immediately below is blocked. The unit of sand attempts to move diagonally down and to the left. Yeah, I think that's what I'm doing actually. So if it's contained there, let's try something here. If it's contained, I continue. Hang on. If it's occupied. Oh, I have this wrong. If it's occupied, why am I struggling here? If the space that I'm trying to move into is occupied, I don't want to check that space. Yeah. So don't check this space. Otherwise, I need to add it to my stack so I can backtrack. So otherwise, I'm gonna say I'm gonna go to that space. And then I need to recursively find the next spot. Okay, that makes sense, but why? I seem to find it fine. The place. Let's try it here without that condition check real quick. Oops. Adds it. All right, I think I'm already wrong. No, that looks okay. So it continues filling in. And then it can't, fills in there, it drops down. Okay. All right, I just had I fixed it there already. I had a little, there was a bug here, so when I only want to check it if it is going to be a valid position. So if next is less than max next dot row, if I'm less than the max row, well then that, I still want to push it. I'm so close here. So if I'm less than the max row, I need to try and drop more sand. That's why I feel like the greater than or equal here. I don't actually want to add the sand if it's off my edge. It decided to add it off the edge. Or occupied.cane's next. Or I think I just had an and here before. Next dot row greater than or equal to max dot row. Let's try that. All right, it looks. I'm super confused by this. Drop sand. Any sand takes for falling forever is shown here. Once all 24 units using the scan showing how many units sand come to rest before. Okay, so it's saying that sand will start flowing off the edge. Okay, so my simulation actually is working well. It's just not stopping properly. So I'm supposed to, as soon as any sand falls off the edge, I think I'm so close. So right here, the sand, my next step should be, it should return false, but it doesn't. It fills in this space. Which I don't quite understand. So I think I'm so close. My logic here, something's not quite right. Because this piece should detect that there's something below it and try to go here, right? If it's the next row, it's almost like I kind of need to like return false as soon as I detect this. Instead, I'm adding it in, which allows me to continue. So if I try to go down and it's not occupied, here, let me try something here. So if it's not occupied, if next dot row greater than or equal to max row, I think it's sort of saying, oh, well, I shouldn't, I'm actually done here. Let's try this. Filling up. There we go. Yeah, so not only do I need to skip it, I need to say, oh, hey, I'm done. I'm done here. I'm trying, this logic feels weird to me. I'm wondering, can I do better? This part here looks a little weird. Don't check this space. This space falls forever. So we're done. Okay. All right. So now we just count the grains of sand. I'm going to change this to thread.sleep. Oh, I guess my actual puzzle input's going to be giant. But now I could watch the sand fall here if I do this. Well, not as cute as I thought it would look, but that's okay. Console.writeLine of wonders dot get my input. It's a good idea. I need to actually report the output. New file input.txt. Oh, I'm so glad I didn't run into any complications this time. The last 2 days were painful. The last 2 days just made me sad. Now I'm off to a good start. Yeah, I made a window. All I have to do is calculate the min and max, and it should be fine. I wanted to verify. Yeah, I'll calculate the min and max of the window, and have it be in there. Let's input. I needed to make a method called public int sand count sand.count, and we want to print out console.writeLine Sand. I haven't tested it. Good call. Do you have correct answer for your test too? I haven't actually checked. Look, I'm just crossing my fingers, right? Sand count. Let's go back to the example just to make sure. Supreme confidence. This puzzle didn't feel too hard. 24? Is that what they want? 24. Okay, let's try it with my input. See if I get an answer. 897. Okay. All right, we got a beautiful gold star here. Part 2. You realize you misread the scan. There isn't an endless void at the bottom of the scan. There's a floor, and you're standing on it. You don't have time to scan the floor, so assume the floor is an infinite horizontal line with a y-coordinate equal to 2 plus the highest y-coordinate. All right, so we have like an infinite line at the bottom. In the example above, the highest y-coordinate of any point is 9, and so the floor is at 11. As if you contain one rock path like infinity to infinity. With the added floor, the example above now looks like this. Let's check it out, Keith. Ooh. That's super cool. Now I have to render it. Keith, you're making my life harder. You're making me need and want to render. To find somewhere safe to stand, you'll need to simulate falling sand until a unit of sand comes to rest at 500,0. Okay, so we're gonna keep pouring sand in until we cannot pour in any more sand. Okay, so what we need to do, our drop sand now has an extra check that says, all right. Do I want to subclass or just modify my part 1? Because this will, here, let's do a commit. Get status. Get commit -m chore. Finish part 1. Day. What's day? 14. Part 1. First path. So I can come back to it if I need to. If we have, if occupied dot contains origin, return false. Okay. So if occupied contains origin, we return false. Our contains just needs to get updated here. I like want to override how our occupied returns, but I'm just gonna write a new method: public static bool contains position p, and we're gonna return occupied dot contains p, or not static, or we have an int max row. Our max row just gets increased by 2. Is that what it is? The highest 2 plus the highest y coordinate of any point in your scan. 2, so the highest plus 2. All right. If it's contained, all right, so we'll do if p dot row is greater than or equal to max row plus 2, then it's occupied. And then we got to change this rather than occupied. We'll do this dot contains. How many places do I have occupied dot contains? Okay. Okay. Nice picture. Ooh, that's a big old pyramid that's all lopsided. Very cool. This reminds me of Lemmings. I don't know if you ever played the game Lemmings, but this reminds me of how the maps looked in Lemmings. That's cool. I didn't make a picture, but part 1, I just used a large text output window. Part 2 was too wide. Yeah, I'm probably not gonna do it. This is all right. So let's I think I've modified it such that it'll work for part 2. Let us make our window bigger. Cave, this now becomes this dot occupied. This dot contains. Lemmings was good, man. I think a couple months ago, every now and then I'll get a new copy. I'll get Lemmings again, some new version, or even the old version, or I'll find the web version and I play it. Lemmings is great. I want to make a class project at some point where students write a Lemmings-like game, because Lemmings is just a sort of, it's a great example of how you can use inheritance, use object-oriented programming to do something. So you program a basic lemming, and then you just have a subclass that overrides their behavior, and then it's just sort of this thing that goes through. Gupta, I did finish packets. It's funny. It's always interesting how when I step away from something, the issue happened to be that I tried to go down this path. My brain really wanted to do it the Haskell functional way, and that just C# does not lend itself to that. C# did not lend itself to that, and it just killed me. I did solve it. I'll show you that if you want to check it out. Actually, I did a couple things. So here's the version. Here's the final version I came up with. Then I ended up been doing these beginner guides for my students. Then this is sort of a less object-oriented. It's still object-oriented. It's a less object-oriented. So my students, I've been making these videos, these guides that are sort of how to approach them. But I'm trying to reduce it to what is the minimum thing you need to understand to do it. So I made another guide here. If you want to check out, where is it? Let's go over to this account so I can find it. My channel. This one here is what I ended up. Oh, pause that. Let's get a share link. If you want to check this out, this ended up being a guide I put together to solve it. So the second link I sent there is the guide solution that I came up with that doesn't use inheritance. I end up using a list of objects, but that just makes it a little bit simpler to think about for new programmers who are beginners. So that's the whole point of my video series here, is the advent of code for beginners. How can you approach these? The hardest part is coming up with an approach, and I just implement a recursive descent parser I was really, really happy with the simplicity of the final solution. I actually think I have a solution here for this. I wanted to change my window to be wider. Let's try 4. Gotta increase the height by 3. Let's make it wider here by a couple. I don't know how much wider I should make it, but let's try that. Let's see if that. See what this looks like. And we'll slow it down just a little bit. Console. No, that's not what I want. .NET run project solution. I gotta change. Hang on. I gotta change one thing here. Macro. Really, I should. All right, so rather than doing this, I'm gonna say max row become this plus 2. Let's try that. I don't know why I have to keep typing this whole thing out. It's driving me crazy. Because I killed the terminal, but I want it to remember. I don't know why it can't remember. Hey, 93, there we go. Looks like a Christmas tree. All right, let us, well, I don't know, cool animation, but I'm glad you like it. Yeah, I set it up, I did my solution using a stack rather than using the system stack, so I have this stack, a backtracker, so I can essentially do a step-by-step. So glad I'm not having to do it. I'm actually probably going to use that puzzle. I love that puzzle so much. I think I'm going to use it to introduce recursive descent parsing to students because it's so simple. You have ints and then you have lists. You have ints and lists, and so that's it. The structure isn't bigger than that. And then we could potentially start adding, okay, well, what is another data type we could add in? How do we detect that? Luckily, you don't have to do any sort of backtracking on that parser because you don't have to identify specific tokens. So it worked out really, really nicely. Let's try our input here. Yeah, so that's usually what I do is I have them write a parser for an abstract syntax tree, but the students have to be more advanced to be able to do that. 2 gold stars. Oh, I did it. Woo! All right, we made it. We made it. I should probably be quieter. There's people sleeping, but they sleep pretty heavy and we're pretty far away. After the last 2 days, I was just so depressed isn't the right word, but so something. This was pretty straightforward. So there's the trick. So the trick to this one, and maybe a naive approach would work. The something that the way you might approach this is not keeping track, not backtracking properly. If you simulate each piece of sand from the start, it's going to be too slow. I think that would be my guess. Oh, maybe I'm wrong. Maybe you can be naive. When you say naive, Keith, do you mean that your solution doesn't do the backtrack? Okay, so if that's the case, that's how I'm going to do my guide. I was going to rewrite it so it backtracks. Yeah, so that's exactly what I do, Gupta. I keep this stack of basically saying, okay, what's the most recent place? So what I might do is if this works, cool. Keith, how long does it take to run? I was worried that it would just be too big to run, so I went ahead and I guess optimized it prematurely, but I just recognized right away that it was just doing depth first search down. Yeah, you could also, here's what's interesting. Oh, here's a thought. So check this out. You could actually do it without simulating any sand dropping. Well, I'm just doing breadth first search. Mine is doing, sorry, depth first search. It does a depth first search until it fills up until it explores every possible space. That's really interesting. That's really interesting. You are doing a search. You're doing a depth first search. You're just doing a search and saying how many spaces are in the puzzle. How many spaces are in the maze? Yeah. So maybe that's how. Yeah, I think that's what I'm gonna do in my video, because in the video from like 2 days ago, I described breadth first search, and so now I'm gonna do one where I say, okay, well, this is a puzzle that's depth first search. But we're trying to figure out how many spaces are in our maze. Yeah. I mean, I actually feel like mine's pretty short. I don't like, this is just a little too long for me, so I'll probably go back and fix it up. All right, Keith, I'm trying to look at your solution. Let's look at it. Solve. We have a point. Mine was called position. Solve. Reread it in. Points. Split them up. Point to point. Yep. Point to point. Clamp. There is. Oh, you've just. What? Why are you defining? I'm curious why you're defining clamp here. You just want a shorthand to clamp it between that. Okay, gotcha. Yeah, I'm sure we'll get a better example of depth first search. I hope so. That's what everyone keeps saying, but I felt like this week has just been. I felt like all of the puzzles were pretty easy, and not that the last two were hard. But you're probably right. The last two weren't actually hard. I just got my breadth first search. I wasn't adding my visited nodes properly. I had it adding visited nodes, but I didn't have it in the right spot, so I just couldn't debug it. And then yesterday, my parser, I went off the rails trying to do something clever, but ended up, God, I felt so stupid yesterday. And of course, everyone's watching me, so then it ends up even worse. Okay, so solve, place rocks. What is, okay, so we have a function. Place rocks. Oh, the monkey business one was, yeah, the monkey business one was just hard because you had to know a little bit about math. Not a little bit, but you had to have seen that math, right? You had to have seen that before. And what do you even Google if you don't know how to do it? So we looped through all of the position. For each target and scan skip. Cave.triad this. What does triad do? Triad. What is tri? Oh, well, what is cave, I guess? What is the data type for cave? Cave. It's a list of points. What is triad doing here? Oh, sorry. No. Sorry. It is a dictionary. I thought it was a list, so my brain couldn't figure it out. So try add current soil rock. Cool. The change, we clamp it. Okay. And then we move to it and we keep trying. Okay. All right, cool. So place rocks. You build up your dictionary of points to soil. Simulates, so this is building, okay, gotcha. This is building up your walls. I understand that. Simulate sand. We're gonna take in our walls. And then we have sort of exit before floor. Okay, so this is like our condition for the first part, second part. Drops. This is the path we take. Then oh, the bottom. This is bottom. I should read the variable names to figure out what it's doing, not just the right hand expression. Origin. Well, true. Okay. And then we loop through. We loop through building up a single drop of sand. No, this does all of the sand. Oh, well. Okay. So we loop through filling up the container. Okay, so this does all of the sand all at once. It does it all at once. It simulates all of the drops. Not bad. Not bad. Straightforward solution. This nesting is a little bit hard for me to read. I would what do mine look like? 4-4. You have like this 4-4 and then wow, which is making me. Mine is just abstracted into different functions, right? So parse segment does a single segment in here. So I would probably tell my students, right? So nothing wrong with this. You have a very similar solution to what I have. The one thing I would tell my students is this is hard for me to look at and decipher at a glance. Break it up into parts. That's it. Aside from that, very straightforward solution. Very straightforward solution. I like it. And then you have a sweet render. All right, what was the thing that you were saying was hard to name, Keith? What did you have trouble naming? Place rocks, just place into the cave. I forgot keeping track of the hill climbing. Forgot to keep track in the hill climbing puzzle for me. I didn't need that. It's on dictionary. We'll add it in even if it exists. Exit before floor. So here's the thing. I knew exactly what this meant. Because I knew the context of the puzzle, I suppose. Yeah, I knew the context of the puzzle. Is part 1. You can name it is part 1. Beautiful, beautiful. All right, we made it. We made it. Let me commit here. I got so much extra crad. Get add, get status. Get add. Get, what did I change in the guide? Get commit dash m chore update day 14 to solve part 2. Oh, well, I'm hoping Smab is just enjoying his day. I hope he's not wrecking his brain just yet. So my absolutely with beginners, you shouldn't have them nesting. My gripe is you should never have more than two nestings. If you have more than 2 nestings, you need to have a really good reason. that's sort of what I tell students. So, you know, if you're looping through like a 3-dimensional array, sure, or a 4-dimensional array, sure. If you're at that point, maybe you should be using a dictionary with subtypes and stuff. It's just hard, in my opinion, and it's not just my opinion, a lot of people feel this way. It's just hard to read your code as it gets more indented to track where things follow from that and what exactly is going on there. A well-named function can really help you out. I actually want to rework my solution a little bit. Here, this is, I think this is basically too long. But yeah, I tell my students, exactly, if you're looping over 2D or 3D spaces, that's allowed. I agree. So Keith, you're absolutely right. There's this fine line of breaking out too many functions or have you right? So there's absolutely a fine line with the over abstraction is bad too, because then it's, well, now I got to keep looking at what that thing does to figure it out. But if you're in a nice IDE, hovering over the function sort of tells you how it works. So you're right. There's a fine line of breaking it up and not. Comments would also make it easier to follow. But since I know what the puzzle is doing, absolutely, Keith. So here, let me ask you this question. So something you want to ask is, if someone doesn't know anything about the problem, can they look at your code and decipher what it is doing? Right? And I'm not, this is such a challenging thing to do in general for any programmer. How can I write code that is written in a way, this is the whole thing of like, oh, well, my code's self-documenting. People say that a lot. And I honestly don't know that there truly is any self-documenting code, because that requires context. And so context is essentially everything. The reason I'm able to sort of decipher what's going on here is because I understand the puzzle. If someone just sat down and looked at this, what does this mean? And you could sort of go through and reason about it and chunk through it. But Keith, thank you so much for sharing. I appreciate it. I appreciate it very much. I'm gonna stream. I think the problem is, how do you write things that new students can read, and how do you write things that your friends and colleagues can read and you can read it yourself in a month? G12345. That's an excellent observation. Who is the intent? Who writing code and saying who is going to read this? When you're writing code, if you're the only person reading it, then you're writing it for yourself, right? If you're working on a team, what is the context that the team has? What is the knowledge that they have? You're absolutely right. Such a good point. When I write code, so for example, the whole point of writing my day 13 in this way that I wrote it is specifically for students, for beginners to understand, right? So writing code for beginners to understand, how can I make it as simple as possible, break it up into chunks, break it into testable pieces. The other thing is testable code. How easy is the code to test, such that someone could go look at, one of the things is unit test, in my mind, should tell a story about what the code does and how it's supposed to work. So if you have good unit tests, you can say, okay, well, what the heck is this thing doing? Let me go look at the unit test. Oh, this is my input, this is my output. This is my precondition, this is my post condition. Good unit tests tell a story. And let me just be completely let me be as honest as possible here. I don't always do it. Like I've said, I have such trouble naming things and writing things in a way that is easy for other people to understand. But I'm constantly trying to say, okay, how can I build something that I can reason about? So that's why I did this parse segment. I said, okay, well, I want a parse segment so I can reason about that component individually. I want a parse cave so I can reason about that component. So that's just my thought. Excellent solution, Keith. I need to grab myself another coffee, but I will be back very, very shortly. I'm not sure what I'm going to work on next. If you're new, thank you so much for hanging out. If I stream almost every morning, at least for the Advent of COVID, I'm streaming every morning. If you have not yet followed, feel free to follow to get that notification of when I will be back tomorrow. I'm only going to stream for another 20 minutes, but I'm going to grab coffee real quick, and I will be right back. Be right back. So enjoy some sweet lo-fi music while I step away for a moment. All right, I am back. Thank you for your patience. Thank you for your patience. I have myself a delicious cup of Don Francisco's coffee. It has I like my coffee black, no sugar, no creamer, but this coffee has just like a hint, ever so hint of butterscotch. And so there's like this really bitter but mild, this mild sweetness that I love. I love this coffee. This one, and then there is a vanilla one I like, so I sort of alternate between the two, give my taste buds something to enjoy. Oh, that's good. Okay, so what do I want to do next? Happy here. we can see, look at this waterfall. This is cool. This ASCII art's so cool. I think it's really neat. Man, the guy, or guys, the people who put this together, I think it's mostly one guy, the people who put this together, bravo to them. They've done such a good job. This has been really, really fun. I will be going on vacation relatively soon though, so I'm not going to be able to finish on day 25. That's the one thing about this that I'm going, oh, well, as we progress, as we get further and further in, what am I going to do? So I actually, my semester ends on the 16th. And so I actually think on day 16, it's going to end up being the last day that I do something, and then we'll miss out on the later days. Let's see if I can think of a guide version. Let's spend a few minutes. I'm only going to do a couple more minutes here, but let's start setting up day 14 guide. And oops. And start thinking about how am I going to break it down? How I'm going to simplify this for a brand new programmer. What's the simplest version we can get that solved? And so I'm going to start, I think, with do I want to teach a depth first search, or do I want to just, I think I'm just going to have him do a simulation, and then, yeah, I think I'll just have him do a simulation. So there's two things here. I want to provide a solution to part one that can break it down step by step. How you test it is important. And then I also want to have the solution that you get easily lead you to the solution for part two. Right, so that there's a trick here of how do you do one that solves part one and is easy to do part two, and this puzzle actually lends itself to that pretty well. But yeah, I should really write a script to do this, because I find I do this a lot. These commands I've been typing every day. And as a programmer, I should add a script to my bash RC to do this, and I just haven't done that yet. Maybe I'll do that right now. CD test. Solution. Yeah, let's write a script. I'm gonna write a script for that. To get it to initialize a project. Maybe I'll do it. Maybe I won't. All right, here we go. So what are the components here? What are in the essence, what's the essence of this puzzle? Yes. The essence of this puzzle. Position. So we're going to have a position. Public record position int row int column. All right, so we have positions. Well, let's use X and Y because the puzzle uses X and Y. I don't like X and Y, but let's use X and Y. We're not dealing with any arrays, so we don't necessarily get confused about X and Y. We're also going to want a parse method. Parse string position. And so this one's going to be tokens equals position dot split, comma, turn new position int dot parse tokens 0, int dot parse tokens 1. All right. And then we'll write a little test here. Position tests. Position tests. Parse position test. Parse position. Position result equals position dot parse 12,7. What did I do? Static. Why is this complaining? Calls ambiguous. This is weird. Position expected equals new position 12,7. Assert equal expected and results. We'll do that a few times. Zero, 0, and 490, 63. Make sure it passes real quick. So we have a very simple position. And we have, what were the other components? We have a cave. Yeah. File new cave. And then I'm gonna model it here where the sand is sort of an actor. So we can watch the sand fall. We can actually watch the sand fall. So we're gonna do an interesting simulation where we can watch sand fall. Sand.cs. Public class sand, and our position can change, so it's not a record. So we have a public position position get private set. Let me ask if anyone's watching and knows, is it considered bad practice to name my variables this way? So I have a class called position and a variable, public field that has the same name as the class. I personally don't like doing this, but I often struggle to come up with a good name for the field. It's fine, okay. So if it was lowercase, it wouldn't bother me so much. So I think it's because I come from the camel case instead of Pascal case for variable names, and it just kind of makes me feel a little crazy. And so we're gonna have in our sand. I know anything else makes for weirdness. I absolutely agree. It's like I want it to be named position, but in my brain I'm going position, and it feels weirdly redundant. I know you can't. You can't mix it up. So the one spot you get it, the one spot where it's possible to mix it up is here, where I do position equals start. Right. So this is the one spot where it might be awkward but the assignment, you can't assign a class. So if you have good syntax highlighting, it doesn't matter. So let's say I had no syntax highlighting when I see the word position at a glance. That's all I mean, is if I don't have syntax highlighting, I might confuse the variable position with the class position at a glance. So syntax highlighting saves me, and I think technically you're supposed to do this, but my, name can be simplified. Remove this. C# for whatever reason doesn't want us to do this dot on variable names, whereas other programming languages say, well, if it's a member field, you should use this dot. All right. So we have a start position. I know C# has. I program in C# and Java, so the AP class, the AP test for Computer Science A is in Java. It's basically a Java course where you have to understand Java the mechanics of Java very well. Not even how to program, just the mechanics of Java. And Java has some weird conventions. Or different. I say C# and Java have different conventions. That's what I'll say. Okay. Let's so we're gonna write a little thing that says position, try and move down. So we're gonna have a public bool step, and the sand we're gonna take in a cave. I gotta make a cave reference first. Public record cave. And I actually think if I just here's such a cool thing about records, I can still do this. Correct. A position. I hate that. I absolutely hate that. That's even worse. Step. All right, so step's gonna say, how am I gonna fall in this cave? And so we're going to basically, step fall. Maybe I'll call it fall. What do you think? Do you think step or fall is better? If you're thinking about simulations, the word step. So my students who know about simulations know, oh, this is my step function. This is how I progress one step. I can also make it, this is what I should do. I should say that a sand is part of a cave. So, like this. There I go, doing it. Cave equals cave. So when I fall, actually, I don't. Here's an interesting thought. Does this puzzle work out the same way if you drop sand all at the same time? I think it does, because it just sort of trickles down. This will be really cool. I have a really cool idea for a visualization on this one. You could just have all the sand simulating simultaneously, where the bottom sand just moves one step before. Ooh, I have an idea. Often when I have ideas, they're bad ideas, though. So hopefully this isn't a bad idea, but often I have bad ideas. So fall basically is going to check, can I move into my next position? So position, I'm going to create some helpers here. So the positions we want to be able to check happen to be down. Technically, the puzzle says not to that. For visualization, I think it'll be cool, though. For visualization, it'll be really, really cool. I know, I understand. For my students' version, I'm not going to do that, but I'm realizing, hey, you can totally do that in this one, where you don't have to simulate each sand at once. Individually, you can actually say, oh, just dump it all in at the same time so the sand will fall, and I think it will percolate through, because I'm probably wrong. Down is going to be new position. x, y plus 1. Correct. That's why I was thinking, oh, it'd be cool to do that. But I'm wondering if, because of the physics of it, but I think if you move the first grain of sand first, it will clear out. Essentially, it's doing what my stack was doing. Public position down left. X minus 1, y plus 1. Public position down right equals new position, x plus 1, y plus 1. Yeah, exactly. That's exactly what I was going to say is, well, the first grain of sand starts, we'll move. You can't have them move in tandem, so you can't do it like you would do with, what is it called? A Game of Life is a cellular automata. It's not a cell. It won't work the way a cellular automata was because all the pieces don't progress all at once. You have to do each individually. So you have to say, okay, everyone step. So, but step in order. The order matters. Okay. So our cave is going to have a method. Is occupied. Is occupied takes in a position P, and it's going to return whether or not it's occupied. Okay. So ball. It's going to check the cave. It's going to say Exactly. So your cave keeps track of what is actually occupied, whereas the sand just asks the cave, hey, is this spot occupied? And the sand doesn't actually determine whether it's occupied. The cave does. So as you're falling, you say, have I hit ground? You're gonna return true if you're still falling, or if you fell. So we're gonna say if position dot down, and say if cave dot is occupied. If the cave is not occupied down, this dot position is going to equal position dot down, and we'll return true. Oh, I like that idea. Falling sand is visualized differently. If cave dot is occupied, position dot down left, this dot position equals position dot down left. Turn true. If the cave dot is not occupied, position dot down right, this dot position equals position dot down right. Return true, return false. All right, so we return true if we fell any, otherwise we return false. All right, this means our caves is occupied has to work. So our cave has to take in a hash set of position walls. What are they called in the puzzle? Rock. All right, so we're going to take in a hash set of position rocks. Or just rocks. I don't know. What's better, Keith? I need you to tell me what's better, the name rock for my hash set or the name rocks, because it's more than one, so I think rocks with an S is the right name. We is occupied if rocks dot contains P. And we need to We're gonna do another single step here. Public bool step. Ooh, we need to keep track of all of our sand. So we also have an origin. Public static. Oh, return false for now. Public static. Read only. Position. Origin equals new position. 500 0. And I guess all right, so drop stimulate grain of sand. I hate this name. What do they call it when it falls? It's called fall. This is why the word step kind of makes sense to me. So we're gonna step once. All right, so we're gonna put a piece of sand. So we're gonna say sand S equals new sand origin this. So that we're gonna put a piece of sand in our cave here. And then we will do well S dot fall. Not do much of anything there. So we just do a well, we just say fall, keep falling. That's interesting. Well, S dot fall. Oh, not quite. Not quite. We actually want to check to see if it's it's fallen off the edge. If the sand if the sand's position is greater than dot y is greater than or equal to we need to get our biggest spot, max row, max y, return false. We weren't able to put this in, the sand fell off. So we need an int max y. Okay. So if we have a max y, we return false. Otherwise, we just keep churning, keep falling. Finally, we get here. We have a public hash set sand. We'll do position. Settled sand equals. We'll do it as a property. This equals new. Otherwise, if the sand can fall all the way to the bottom, return false here. The sand gets added here. Settled sand add s dot position, and we return true. Yeah, so I'm about to. I think I'm gonna write myself a nifty little visualizer using this. I think. Oh, I know I said I was gonna stop after 2 hours, but I really should. I have to teach a class here in an hour. I'm so close to having the simple version done though. Let us still our display cave. No problem, G. Thank you so much for stopping by. I hope you'll come back tomorrow. It was lovely meeting you. It's lovely chatting with you. And I really hope you'll come back. You're welcome back anytime. You're welcome back anytime. Take care. We're gonna just do a print like this, and we are gonna say string. We're gonna have it just calculate the min and max of it to start out. Yeah, so we'll just have it do the min and max. It'll find it. When we make one of these, we can do a public position like this. Public position top left. And public position bottom right. And can I somehow initialize this? Can I do this? Position top right. And we're gonna just have a method here called calculate bounds, find bounds. I do this, and then if I do a public static position top left, position bottom right, find bounds, set position tops. I'm gonna give this a name. Bounds bottom right. Here we go. I like this. And I will put this in position. Find bounds. So this becomes position dot find bounds, and this becomes bounds dot bottom right dot walk. All right. Let's keep going here. Find bounds, I'm going to say for each position key in rocks, and we'll just call this positions. And we'll start position top left equals new position math a top dot or int dot min value, int dot min value. Bottom right. Oh, TL BR max. Oh, hang on. Top left. Got these mixed up. We started the max on these. We're gonna say if position dot x is less than let me do this in a clever way. Yeah, TL equals new position with we'll do top, yeah, int top equals position dot y math dot min position dot y tl dot, here we go, even better, int top starts at int dot max. Actually, we're gonna have our top start at 0 because that's sort of where our cave starts. Int bottom equals 0, int left equals int dot min value, int right equals int dot max value. Or this should start at min value. This should start at max value. Our new top happens to be our Y position or our current top. Our bottom becomes the max. Our left becomes the min. Our right becomes the max. Right, like that. And we're going to return new position, our top left, or left top. It's XY. New position, right bottom. Top left, bottom right. Okay. Whew. That was an annoying part of that. Is occupied here. So we're gonna say it's actually I was gonna say is occupied public bool is at bottom. We're gonna have two things. Say if we're is at the bottom. So if we're at the bottom, return p.y is greater than or equal to bounds dot bottom dot y. That way, our check here, we can write a subclass of cave and make is at bottom have +2 in it, and we don't have to rewrite anything. So is at bottom if is at bottom s dot position, return false. Okay. Oh, I was in the middle of writing this print. That's right. I wanted to do, yeah, for each, I wanted to get the bounds. That's right. So position top left, position bottom right equals position dot find bounds rocks. And then we'll do, I want to add a padding. So I want to give it a padding of 1. So I'm going to add in here one more thing. Int padding equals 0 by default. So we're going to add pad on each side. So the left, we're going to subtract -1, -1, +1. Oh no, plus padding. Okay. Give it a padding of 1. top left dot y, top left dot x, bottom right dot x, and this becomes position column row. This dot is occupied. And then settled sand. Settled sand. All right. Let's see. We can get this new version to work. I already have a program. Okay. New version. Gonna be a little bit different. We had, oh, I haven't written my parse yet for my cave. Okay. So I need to still those here. We're gonna do a parse and a parse segment. And we no longer need to do this while we're building it up. And parse segment, start and end. These become diff y, diff x. We'll do x, y like this. X, x, y, 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 x. And we gotta switch those around. Keep on going. And then we're gonna do, this has a step. Yeah, step. Well of wonders dot step. Get rid of this. This should be of wonders dot settled sand dot count. And we'll try print project solution. I have to put my example in there. Example. Like that. It's a little brute forcey. Oh no. Am I even? Where am I doing recursion? I should read that error. Should have read the error. Here, let's read that error. Project solution. Position constructor. Oh. These need to be properties. Okay. Okay. Is occupied if rocks contains it or settled sand contains P. There we go. Okay, so we have that. I like it. And what we're gonna do is actually we can get the sand to drop, like we can watch the sand fall. If I want to watch the sand fall. So I'm gonna do a public void. Can I do? Yeah. Public void. Animate. So animate's gonna do our thing here. All right, so this solution, let me make sure it works for the big input as well. Get my input here. Make sure it works for the input. I don't want to do that. I wanted to do input.txt. All right, so I wrote it a second time. Seems to be working. .NET run project solution. And I'm gonna have to zoom out. See if we can zoom out. I don't think I can zoom out far enough for the console to clear to work out for us. Hang on, let me try again. Oh, yeah. Let's have it. Bet I could do. Can I zoom out anymore? Is that as far as my turn? Let's keep going. Weird. My terminal, it won't let me be bigger than that. That's funny. That's too bad. I really wanted to visualize it. What's interesting, so here I have a thought. We could, all right, so here's, how wide do we go? It's not even that wide, it's just super tall. I want to watch the grain falling. Right. Let me commit this because this is the solution here. Let's not. .NET run project solution. I really gotta go. 897. That was the right answer, right? 8. Okay. And okay, so we can simulate this in. I really want to get. I haven't written my test yet. Get commit machine chore. First draft of guide, day 14. Can I make it so I can follow the sand? All right, so I want in my cave, I want to add in an animate. Let me zoom back in here. Ah, too big. I want to add in an animate. So the animate, public void animate, is going to keep redrawing the screen. I honestly feel like the air should just be a plus, a space here. What I think I want to do is make it so that we do something intelligent here, so we're not redrawing every position over and over. But that's we'll get there. Animate is going to do essentially this. It wants to call, like, for at the bottom we return. And each fall step. So here we go. Right here, we're gonna do console.clear print, and then every time we call fall, we'll print it out like that. All right, let's try that. Of wonders.animate. Oops. .animate. Why? Why do my fingers betray me? Solution. Oh, and then I need to... That's interesting. And then I need to loop over this whole thing. Wow. True. Yeah, well, true. And then thread.sleep 25. All right, and then we're gonna make print more efficient. We're gonna have to add in a more efficient print. .NET run project solution. Oh, and the sand needs to draw itself. So let's add in a falling print sand question mark falling null by default. We'll say if falling dot position is p, else if console dot write, have that be falling. All right. Do we have it this time? .NET run project solution. No. Oh, I never pass it in. Hang on. I need to stop closing that. Print S. Okay. There we go. Ooh, now we get the falling sound. All right. So, can I make my print? So I want to see if I can make the animate not redraw the entire screen. So we're gonna do a public void init print, and so this is going to draw all of the hashes. So it's going to draw all of the hashes. It's going to clear the screen, draw all of the hashes, and then we only animate the actual falling of the... So we have to like delete and redraw based on the position of our grid of where our sand is. So we kind of need to make sure we have our bounds in our animate here so we can get the correct offset. So we're gonna init print draw sand S. And we'll make it so draw sand. Draw sand S. Oh, interesting. Because after we move. Alright, so we'll do position prev equals S dot position. Clear sand. It's going to take in our previous position, and then we draw the sand. So we have to clear the sand, so we have to remove it from the previous spot, and then add it to the next spot at the bottom. So we have two here. Public static void draw sand S sand. Really, this just needs to be a position P and our bounds top left bottom right. And I'm just gonna make this draw symbol. Yeah, here. CH. And we're gonna draw symbol. I don't even need to find this, do I? This is our bounds. Oh. That's fine. I'll do this. This is inefficient, but I'm gonna do this. I gotta hurry. I gotta quit. I gotta get off here soon. I'm so close. We're gonna draw the symbol star. At position P. Top left. Really, we need padding. Int padding. That's really all we care about, because our positions shouldn't matter there. All right, we're gonna draw it at our S dot position with a padding of 1. Draw symbol blank at prev dot prev. Our start head, we've moved, so we're gonna do that. Let's swap this to a do while. So we want to draw the sand no matter what. So we're going to draw the sand. Then we're going to so prev equals the sand's position. Yeah, we'll do a thread dot sleep here. And then we'll draw, we'll erase it and draw the next one. Okay. Okay. So draw symbol console dot set cursor position to P dot, what is this taking left? P dot X, P dot Y, but our padding has offset us by some amount. So is it plus my padding? I think plus padding. Plus padding. Console dot set console dot color, foreground color, equals console color dot, let's make our sand yellow. Console dot right DH, and then console dot reset color. Okay, and then when our sand gets to the bottom, we need to draw, ooh, let's do a color. Console color. I don't actually need to reset the color, I don't think. Draw symbol, console color dot dark yellow. Console color dot black. And then the sand hit the bottom. We're going to turn it to an O and make it just yellow. Maybe we should make this one dark yellow and this one yellow. We're gonna go with that. And then let's make all of our inits. Let's make these console dot foreground color, console color dot gray. Okay. And at the very end of this whole thing, we will do console dot reset. Okay. All right, that was a lot without testing. Solution. Oh. Let's see, where am I? Padding. Oh, it's like yeah. Hang on. Yeah, because we init. So I do need my bounds in there to figure it out. So I was wrong. Not padding. This needs to be position top left, position bottom right, bounds. So I need to do a translation by that. All right, so this should be bounds. So the padding is equal to, I'm starting at my top left. This is 0. So so I should be minus top left dot bounds dot top left dot x minus, all right, off x equals top left bounds dot top left dot x, and then I have a padding, so I think it's +1, and then int off y is bounds dot top left dot y +1, which should be 0. Then we'll do our off x, off y. Come on. Actual value is -1. Is there no offset here? I'm pretty sure I need that. I'm close. We almost have it. And I need to move the cursor after I write it. Console.set cursor position 0, 0. So that we don't see it moving. Can I make my cursor? All right. console.cursor size cursor visible equals false. Let me do this. No. Do you think I can make my y +1? Or -1? Let's try it again. Oh god. Let's get rid of this. -1? This just feels... Why does that work? I don't quite understand that. I bet that one's supposed to be +1 as well. No, -1. I don't understand the -1. Say it. Okay, I have an animated version, which I think is super fun. I wish I could hide my cursor or change the symbol of it. That's fun. Alright, so at the start of animate, we will hide our cursor. At the end, we'll set it to true. This should just be a go to end. Label? How do I add a label? Labels. C# go to. End. Oh, it has to be. There we go. Don't use go-tos, children. Oh, I can just break. I thought I was in a nested loop. Oh, I am in a nested loop. All right, so this is go to end. There we go. All right. That made me so happy. I wish the big input was a little bit not so tall. It's a little too tall. But let's I'm gonna do something real quick. This C dot copy day 14 guide to day 14 visual. Get add. Sure, added fun animation. I wish I could make my terminal smaller. Can I do it in the command prompt? Can I get super tiny in the command prompt? Can I zoom out in here? PowerShell is so ugly. What if I open up Bash? can I make this smaller? Looks like there's a limit, but we can try it. We're gonna try it. We're gonna go here. CD. Run. Did I not? The handle is invalid. On line 3. Oh, in this one, it won't let me set the cursor. Just turns out that this terminal lets me set the cursor visible. So let us do cursor visible public hide cursor cursor public void cursor visible bool to set try console.cursor visible equals to set catch. We'll ignore that. And we'll just do cursor visible false, cursor visible true. Not console.cursor visible. How do we do now? Did I close that? No, here it is. The handle is invalid. Well, yeah, that's why I did a try. Online 33. Does it just not have the new? Oh, am I editing? I'm editing the wrong one. That makes sense. Okay, 14 visual. Okay. And now in my cave, I'm adding in a public void cursor visible bool visible try this catch cursor visible false cursor visible true. The handle is invalid. Clear? I can't call clear? What a... This terminal's terrible. Terminal's terrible. Jeez, what an... I'm amazed that it works here. I want you to be better. Well, I guess it'll kind of work on a giant input because I'm not clearing the screen over and over, and then it'll just eventually go off the edge there. Let's add in, do we have the full input here? Yeah, let's try it here. And then I really got to go 5 minutes. I've gone way longer than I wanted to, than I thought I would. That's funny. Not exactly what I thought was going to have happen. Let's fix that real quick. So in this case, oh my goodness, I keep saying I'm gonna go, but I keep going. Oh, I still gotta prep my class. Not really, I'm mostly prepped. Today's the last day for this class, actually. So init, we'll do a clear, and then if it's occupied, we're gonna do the following. If it's occupied, draw symbol, hash at p bounds, and console color gray. All right, so this should get us. And if we get out of bounds, all right, so try. If at first you do not succeed, use a try. Is that a terrible saying? Not a saying, I suppose. Hey, hey. Oh, this is gonna take a while, isn't it? Let's speed it up. Let's speed it up. Thread.sleep, we'll call animate int delay equals 25 by default. We'll have this do a delay, and let's try a delay of 1. All right, let us. Can I make this? I want this to be, well, wrong way. Let's zoom out. Let's zoom out. That's as small as it'll let me go. And unfortunately, when I do a click, ooh, is it gonna work this time? .NET run project solution. Oh, here we go. Wow. All I gotta do now is record it. And I actually think I can send multiple grains of sand at a time, right? All right. Zoom in and see. See, that's what happens if I zoom in though. .NET run project solution. Oh. Let's close this. Let's animate 0. Let's have it just go. Be as fast as you can go is what I'm telling it. So as fast as it can move that. And I'm too zoomed in now. I wish I could sleep for half a second, and then of course I get off the end there. That's disappointing, but I gotta zoom out one more, I think. The clear messes it up. What? Or is it the fact that I'm changing size that's messing it up? We can see it. We can see the little dot there. That's nice. Okay. Okay. Fun. Okay, I'm done. I gotta go. Thanks for watching. If you made it this far, if anyone's still here, you want to see me live stream some more, feel free to follow. As always, keep on coding. Hope you continue growing. And you're welcome back anytime. Have a beautiful day.